Okay, quick question for you. What generates 5,000 degrees of heat, 218 decibels of sound, and fits comfortably right on your thumbnail? Just think about that for a second. You're probably picturing some highly classified micro-explosive, right? Or maybe some advanced military-grade hardware developed in a secret underground lab? Well, you'd be entirely wrong. Welcome to this explainer. Today, we are officially declassifying nature's most powerful biological weapon, the sonic cannon. We're looking at a creature that somehow managed to weaponize complex physics millions of years before human beings even understood the math behind it. This isn't just biology, folks. This is a story about uncovering a terrifying hidden technology designed by evolution itself.
Meet the pistol shrimp. We're talking about a tiny crustacean, barely 2 inches long, weighing almost nothing. But it's armed with this incredibly oversized, wildly asymmetrical claw. And here is the absolutely crucial point to understand right out of the gate. This claw doesn't act like a normal pair of biological scissors meant to cut or grip. Not at all. It acts exactly like a loaded spring in a barrel. It's built entirely like a firearm. One side of the claw stays completely stationary. That's the barrel of your weapon. While the other side cocks backward nearly 90 degrees. It literally locks immense muscular tension into this tiny, fragile-looking frame.
Now, for a very long time, science fundamentally misunderstood how this weapon actually worked. The old myth of the 20th century was that the unbelievably loud snap you hear when this creature attacks was simply mechanical. Just the two hard, calcified halves of the claw violently slamming together. But in the year 2000, researchers pointed high-speed cameras at the shrimp, capturing an astonishing 40,000 frames per second. And what they revealed was a shocking modern reality. The claw closes so incredibly fast that it doesn't just hit itself. It actually shoots a high-velocity jet of water straight out of a microscopic groove between the two halves. The physics that happen immediately after that jet fires, they are downright terrifying. That tiny jet of water is moving at roughly 60 miles per hour, and as it rushes forward, it pulls the surrounding water with it so fast that it creates a massive, instantaneous drop in pressure right behind the jet. When pressure drops far enough, the ocean water is literally ripped apart. It instantly vaporizes, turning into a gas without any heat being applied whatsoever. This creates a vacuum bubble. This process is called cavitation. Human engineers have actually known about it for a century, and they absolutely hate it because the violent forces involved easily destroy solid steel ship propellers and heavy industrial turbines. But the pistol shrimp, it evolved to deliberately harness cavitation as a localized, highly destructive weapon. Let's break down this attack sequence, because it is a biological masterpiece of destruction. Step 1, that immense muscular tension snapshot. Step 2, the water jet launches forward like a bullet. Step 3, the low-pressure vacuum creates that cavitation bubble. Step 4, the surrounding ocean, which is suddenly under immense pressure, violently slams back inward, collapsing the bubble in on itself. And finally, Step 5, a massive shockwave and a blinding flash of energy are released into the water. Now, the truly mind-blowing part about this entire chaotic, multi-stage chain reaction, it all happens in under 300 microseconds. That is a fraction of a single millisecond. To truly grasp the awe-inspiring scale of this weapon, we need to look at the raw numbers generated inside that microscopic window of time. Let's start with 62. The water jet that forms the initial bubble is traveling at 62 miles per hour, right at the exact moment of collapse. That is literal highway speed, completely underwater, generated by an animal essentially the size of a standard paperclip. Next up is 2000. When that bubble implodes, the water has absolutely nowhere to go but inward, compressing with a force that just defies common sense. Theoretical models put the peak pressure inside that collapse at up to 2,000 bar. To put that staggering number into perspective for you, that is the exact same crushing pressure you'd experience if you were sitting at the very bottom of the deepest, darkest oceanic trenches on planet Earth. And it's all concentrated into an area the size of a millimeter. And in terms of sheer sonic output, the numbers are equally absurd. A roaring, multi-ton commercial jet engine taking off clocks in at roughly 140 decibels. A firing gun sits at a deafening 165 decibels. The pistol shrimp, it dominates them all at an ear-shattering 218 decibels. A creature you can easily hide in the closed palm of your hand produces a sound wave that effortlessly dwarfs the most powerful human artillery.
But hold on, we aren't done yet. The ultimate extreme here is 5,000. When the cavitation bubble completely collapses, the kinetic energy concentrates so intensely that researchers have measured temperatures reaching up to 5,000 Kelvin inside that tiny pocket of space. For context, the entire surface of our sun is about 5,700 Kelvin. So inside a volume barely larger than a grain of sand, sitting in the cool ocean, this tiny crustacean briefly summons the blazing heat of a literal star.
Because it gets so unimaginably hot, something straight out of science fiction happens. It's a phenomenon called sonoluminescence. It's a brief, intense flash of light produced entirely from the extreme heat of a sound-driven bubble collapse. The shrimp is literally creating pure light out of sound. Now, the flash only lasts about 10 nanoseconds, so fast your naked eye physically cannot process it, but when researchers aim high-tech photodetectors at the shrimp, it registers perfectly. It's the definitive, undeniable proof of the solar-level temperatures at play here.
So how is this actually applied tactically out in the wild? Well, it's what I like to call the 300 microsecond kill. The shrimp waits patiently inside its burrow. A small fish or a crab swims by. The shrimp doesn't chase it, it doesn't wrestle it, it aims and it fires. The resulting acoustic shockwave hits the fish so incredibly fast, again under 300 microseconds, that the fish's biological nervous system literally cannot react. The shockwave stuns or outright kills the prey before the brain can even send a signal to flinch. It is an attack fundamentally faster than a biological escape reflex. No warning, just lights out.
But there is one massive catch to all of this. This heavy artillery, it's nearly blind. It possesses this incredible, world-class weapon, but it cannot effectively see its targets. So it evolved a perfect military partnership. The shrimp acts as the heavily armed, visually impaired artillery down in the safety of the burrow. Its partner, the goby fish, acts as the spotter. See, the goby has excellent eyesight, but absolutely no weapons to defend itself. So they live together in this tactical symbiosis. The goby stands guard at the entrance, and the shrimp keeps one single long antenna touching the goby's tail at all times. Just a tiny, imperceptible flick of the goby's tail signals an incoming threat, and boom, they both instantly vanish into the burrow.
This claw isn't just a sniper rifle, though. It's a biological Swiss Army knife built entirely around one extreme physics principle. The shrimp uses the snap for hunting, defending against predators, communicating with rivals, excavating hard rock for its burrow, and even signaling across colonies. But here's the absolute most fascinating detail. If the primary weapon arm is ever severed or ripped off in a fight, the smaller normal claw on the shrimp's other side will actually morph and regenerate into a brand new sonic cannon. Meanwhile, the missing arm grows back as a regular small pincer. It can literally reassign its primary weapon system to its other arm. It's just wild.
All right, let's zoom out to a massive scale for a second. When thousands of these shrimp live together in a coral reef, their continuous overlapping snapping creates the loudest continuous sound in the shallow ocean. Divers say it actually sounds exactly like giant pans of frying bacon. But the sound is so intense, it became a literal military asset. During World War II, this crackling wall of noise accidentally masked the sonar signatures of Allied submarines. The military realized this and actively sought out and positioned their subs near shrimp colonies, using this biological acoustic camouflage to slip past enemy lines completely undetected.
And some species take this cooperation to a terrifying extreme. Enter Synalphes regalis. They don't just live in loose groups, they operate a literal caste-based civilization hidden deep inside sea sponges. These specific pistol shrimp are eusocial, which means they operate exactly like a colony of bees or ants. They have a single reproductive queen and an entire standing army of male soldiers equipped with oversized sonic claws dedicated solely to guarding the perimeter of the sponge while workers maintain the interior. They didn't just evolve a weapon, they built a heavily fortified society entirely around it. Naturally, human engineers are desperately scrambling to reverse engineer and steal this natural perfection. Today, medical researchers are using precisely controlled cavitation pulses, literally mimicking the shrimp's attack, to blast apart human kidney stones without surgery, and even temporarily open cell walls for perfectly targeted cancer drug delivery. Industrial engineers are using specialized cavitation jets for microscopic surface cleaning and to bombard and strengthen metals for commercial aircraft. Researchers are even 3D printing biomimetic mechanical claws that genuinely reproduce this cavitation plasma right in the lab. But beyond mimicking their technology, we're also using the shrimp themselves as ecological wiretaps. Dropping a hydrophone into the ocean to listen for the crackle of this sonic artillery is now one of the absolute best, non-invasive ways to measure the overall health and biodiversity of a coral reef. A loud reef is a healthy, thriving reef. Silence, or a sudden drop in snapping, means the entire ecosystem is dying. So this tiny creature basically acts as an incredibly sensitive biological sensor for the entire ocean. Which brings us to a final, slightly terrifying takeaway.
If a tiny, nearly brainless crustacean can patiently out-engineer our most advanced physics labs, effortlessly turning water into plasma and sound into pure light, what other military-grade technology is evolution hiding out there in the dark? Nature doesn't need research funding, lab goats, or a decade of development. It just selects what works over millions of years until it achieves brutal, undeniable perfection. Thanks for joining me on this explainer. Keep wondering, keep exploring, and I'll catch you on the next one.